Hey everyone, in this video we are going to solve the intersection of two linked list question on Leetcode. So we are given the head of two linked lists and we have to return the node at which the two of the linked list intersect. And if there is no intersection at any point, then we need to return null as the output. So as you can see in this diagram, we have two linked lists A and B, and they both intersect at this point C1, and we need to find and return that C1 as an output. Also, a follow-up part of this question says that is it possible for you to run this to code it up in O of m plus n time complexity and O of 1 space complexity. So let's see how we can do it. The first way to solve this is pretty easy. So what we can do, we can loop through both of the linked list and keep adding the values in a set or in an object. So let's say we have a set, we loop through the first linked list and we keep adding the nodes we are visiting. So we'll keep adding A1, then A2, then C1, then C2, then C3. And then after that, we loop through the other linked list. We'll start from B1, then B2, then B3. And we'll keep checking if the element or the node is already present in our set. And as soon as we found it, so when we go from B3 to C1, we'll found that C1 is already present in our set, and this will be our intersection point, and we'll just return it. So that will be a pretty easy solution, but that will require some extra space. There is one more way to solve this question. So what if we have the difference of length of both of these linked lists? So the first one, L1, let's say, it has a length of 5, and L2, the other linked list, has a length of 6. And the difference between them is 1. So we know if we move the longer linked list one step forward. So so the first one is here and the another one is here, and we know the difference between both of these lengths is 1. So we need to move the longer one just one step forward. So if we move it from here to here, now both of these linked lists uh, are at almost same position in terms of their length. So what we can do, we can just move forward both of them one at a time, and as soon as we reach a node that is common, we have found the intersection of the linked list. So what we'll do, we'll move from the left one from here to here, then the right one from here to here, then again the L1 here, and then the R1 here. Now both of them are at the same node, and we have found that this one is the intersection, and we'll return it. But the tricky part is, how do we know the length of the linked list? So to do that, what we can do, we first traverse through the first linked list, L1, and we keep a count. Let's call it count A, and we keep going for through the linked list until we reach the end null. Until the linked list becomes null, until we finish the end of the linked list, we'll keep moving forward and we'll keep updating our counter. So for the first linked list, when we do so, we'll get a value of 5. Similarly for B, we have another counter, count B, and we'll start from the start of the linked list all the way till it's become null, and we'll keep updating our counter. So if we do so for the second linked list, we'll get a value of 6. Then we calculate the difference of both of these two. So the difference will be 1. Count A, whichever one is bigger. We'll also check that which one is bigger. Then we subtract the smaller one from the bigger one. We get the difference, 6 minus 5 to 1. Then we know that we need to move the bigger one step forward. And if we do so, the time complexity will be O of m plus n, where m is the length of one linked list, n is the length of the other linked list, and the space will remain O of 1, since we are not since we are not storing anything anywhere. So this is the approach we can use. Let's see how we can do it in code. So first let's declare our variables count A to calculate the length of list A. Similarly, a head AB, a temporary head variable, to point to our to point to the head of first linked list. Similarly, then count B to get the length of second linked list, and a head BP to point to the head of the second linked list. Next, we need to loop through the first linked list. So while head AP does exist, so until we reach the end of the first linked list, what we'll do, we'll update the first counter, count A plus plus, and we'll keep moving the head AP forward. So head AP equals to head AP dot next. Now we need to do the same thing for the other linked list. So while head BP will update the value of count B by 1, and will keep moving the head one step forward. So BP equals to head BP dot next. Now once we have calculated both of these lengths, so we need to calculate the difference. First, let's reset the heads. So point again head AP to start of the first linked list, and head BP to start of the second linked list. Now let's check which one of the difference was bigger. So if count A is greater than count B, that means the first linked list was bigger than the second one. So in that case, first calculate the difference. So difference equals to count A minus count B, and while difference is there, we move the head A forward because we know that head A was of greater length. So head AP equals to head AP dot next, and we keep reducing the difference by 1. Else, if count A was less than count B, that means the bigger length of the linked list with bigger length was linked list B. So again we calculate the difference. So difference equals to this time count B minus count A, and while difference is not equal to 0, we'll keep moving the head B one step forward. So head B dot next, and we'll keep reducing the value of difference by 1. Now at this point, both of our pointers head AB and head BP are at same position in terms of the length of both of the linked list. Now we can move both of them one step at a time forward, and at the end we'll return any one of them as soon as we got a same value. So what we can do, we can run a while loop while head AP exist and head BP exist, and head AP is not equals to head BP. So until both of the pointers have different value, both of the nodes have different value, and they are not null. So until this condition is true, we'll keep moving both of our pointers one step forward. So head AP will be equals to head AP dot next, and head BP will be equals to head BP dot next. Now when this loop will break, we would have find our point of intersection, and if such a point doesn't exist, that means both of the list would have reached to the null. Both of these linked lists will have reached to their end. So in that case, the value of both of the head AP and head BP will be null. So we'll just return either one of them. So this is the code. Let's run it. It's working. Let's submit it. Okay, we got one wrong answer. Okay, so my bad. So when we were moving the head B forward inside the else condition, I read head B instead of head BP. Okay, let's submit it again. Cool. So that was it for this video. Thank you for watching.